Hello, everyone. I want to discuss section 3.4, other units for solution concentrations. The learning objectives here define the concentrations of units of mass percentage, mass volume percentage, parts per million, and parts per billion, and perform computations relating a solution's concentration and its components, volume, and or masses using these units. We had introduced the measure of concentration called molarity in the previous section. That is the one we will be using pretty much exclusively throughout most of the rest of this this semester. We'll be introducing a few more towards the end as well. But in the context, outside of the context of a chemistry course, we do measure solution concentrations in other ways. So this seems like a convenient place to discuss those measures of concentration a little bit and how you would go about performing those calculations. For the most part, we'll be using molarity, but you should be familiar with these other ones as well. So the first one is the mass percentage. So the mass percentage is defined as the mass of the component you care about divided by the mass of the entire solution and then times 100%. This percentage is sometimes also called the percent mass, percent weight, or weight percent. So all of those are referring to the same thing. So you want to be able to do this kind of a calculation. And this is an example of something that we might see in commercial products. So if you see something that says it's a certain percent composition, so here we're seeing an example of a bottle of bleach has a percent composition on it. That's what that's referring to. So you would be able to calculate that and figure out what mass of bleach is in the bottle or in a sample from that bottle, and then even convert that to moles if you cared about that. So it's helpful to know how these are measured in commercial products, and we could, if we wanted to, convert to moles to get it something that might be more useful for us in the lab. So there are some examples here. I recommend that you look at those. I did want to look actually at this example specifically, 3.23. Because it does bring in some new ideas that I think will be helpful, not just now, but in future future module when we come back and add a few more measures of concentration. So the question here is that we're given this sample of hydrochloric acid has a mass percent of 37.2%, and the density of the solution is 1.19 grams per milliliter. We want to know the mass of HCl contained in 0.5 liters of this solution. I'm going to skip over this discussion that's sort of a kind of guessing at it, because we can do better than that. And look at the information we're given and figure out how would we set up a conversion with that information that would get us to where we need to go. And we're basically given three things. We're given this percent, so this is a percent by mass. We're given a density, and we're given a volume. And when we're given this lots of information like this, we're probably going to be using all of it. And we want to know how to set up our conversion factor. Where should we start? Which of these measurements should we start with? Because it doesn't tell us. And so the rule of thumb that I always have for this is start with the one that has only one unit. Start with the one that has only one unit. So if you look at 37.2%, you might initially think that's one unit. But remember, with a mass percent, what we're talking about is mass of component over mass of solution. So that is actually 2 units, and that is something we'll be probably using as a conversion factor. Density, of course, we see has grams per milliliter, so that is also 2 units. So we have the volume, 0.500 liters, has only the unit, the volume unit involved. So this is probably where we want to start. So we're showing a roadmap here of the process. So we have the volume of the solution. And then in terms of these other two, we want to pick one that can get rid of those units of volume. And we see that in density, we have volume, grams per milliliter. So we can use that as our conversion factor. This one does not, right, because it's a percent by mass. So we convert with density to mass of solution. So we're setting this up so that the volumes are canceling and we're left with grams. And then this is where we use the percent by mass, because this is mass of solute per mass of solution. So we have mass of solution. We set this up so the mass of solution cancels out, and we get the mass of the specific component that we care about. Okay, so this is the kind of the general roadmap for a question like this. And then here we're showing the process with the numbers we're given. So feel free to look at that a bit more. If you like, you'll see another one similar to this a bit later with a different measure of concentration. So you want to be familiar enough with it so that you can do that other example when you get to it. Okay, the next measure of concentration I want to talk about is the volume percentage. This is defined similarly to how we defined the mass percent, but here we're, of course, using volume instead of mass. So volume of solute divided by volume of solution. One thing I want to mention that your book doesn't talk about, but it's something that's important to be aware of, is that technically this measure of concentration is not always the greatest because volume is not conserved in the same way that mass is conserved. So we can always use mass percent, because we know when we mix things together, the mass of the component is the same in the solution as it would be by itself. It doesn't change. However, it turns out that when we mix solutions together, sometimes the volume can change as we do that. So just be aware that volume percent is a little bit tricky sometimes, but it is a helpful thing to use when we're using liquids that are relatively dilute and that mix well together, because it's easier to measure volume than mass in some cases. Okay, so the calculations you would be doing here would be similar to those for the mass percent. So I will let you investigate those kind of on your own. The next one is technically not a percent if we define it kind of strictly mathematically, but it is often used as a way of discussing things, especially in medical applications, and that's the mass volume percent. So this is a ratio of the mass of the solute to the volume, the total volume of the solution. We generally would use grams and milliliters here as the things that go into it. So technically it's not a percentage, but we are calling it that in these fields where they use this. So just kind of be aware that is what's going on with that. The next two are percentages that we, or measures of concentration, I should say, that we use for particularly highly diluted situations, where instead of writing, a bunch of zeros or even using scientific notation, we just have a new unit, and we call these parts per million or parts per billion. And these are basically like a percent, except that instead of doing it per 100, we're doing it per million or per billion. So where you would normally take a percent by mass and multiply it by 100%, for a ppm, we would multiply it by a million. So instead of by 100, it would be by a million. So 10 times 10 to the 6th. Similarly, for ppb, parts per billion, we multiply it by a billion, so 10 to the 9th. So same basic idea of what we had for percent by mass, but it's not a percent, it's a ppm or ppb. Again, these are often used with things where we have something that is very toxic and we need to have very low concentrations of it to be safe. So we have thresholds that are expressed in these types of terms for certain things that have safety or health concerns. So some examples here of doing calculations with those as well. So that is it for section 3.4. And we're essentially done with module 3. So please take some time to work on the worksheets, contribute to the discussion board, take the quiz before the due date, and please see me, use the discussion board, or see a tutor if you have any questions.